Let's take a moment and sort of summarize the things we found out about this simple RC filter. Again, when we measure across the capacitor, we find that this is a low pass filter. And then when we measure across the resistor, we find that we get a high pass filter. And for either one of these circuits, regardless of whether it's a low pass or high pass filter, the corner frequency where this filter begins to operate is defined as 1 over RC. Now, a couple things to note is that the order of these two components doesn't matter. So you can have the resistor in front of the capacitor in front of the resistor. That order doesn't matter. The second thing that we want to note is that these are called first order filters because the transfer function only has a single W term. There's not a squared term in it. These are also pretty simple circuits to construct. I mean, honestly, you just need a resistor and a capacitor. And they need to balance each other to get to the right corner frequency, but they require very few components. A trade-off, though, is that you cannot control the quality. And so these filters are going to have sort of a fixed roll-off. So if I was looking at the behavior of this filter, and its roll-off was like this, and I wanted the roll-off to be much sharper, there's nothing I can do with this particular circuit. I can't actually adjust how sharp this line is to make it pull back. What we'll see in a bit is how when we have second order circuits, we can actually control that roll-off, but we can't do anything about it if we just have two components. And the fourth bit is that we can only have low pass and high pass filters from a simple RC circuit. We cannot create band pass or band reject filters with just these two components. We'll either need to add inductors to make second order circuits, or we will have to include op amps and other circuitry or cascade these signals to make more complex filters.